Alrighty guys, this video is going to be me going through this entire study guide to explain what to do on each problem and make sure you understand what you're doing. Now the goal for this is you have to complete the study guide first, okay, and then you would watch the video to see if you got all your answers correct, or you were stuck on an answer and you didn't know what to do, so you look at mine to figure out what you need to do. It is simply not for you to copy my answers down and receive the credit for doing the study guide. Okay? If you just copy my answers down, you will not be ready for this test. Right? So, let's get started with real numbers. So, we are asked to list all sets to which each number belongs. Okay? Now, this time we are going to be asked to list all of them out that they belong to. And so we have to remember what these numbers, or not numbers, I'm sorry, what these letters mean. R stands for real numbers, and obviously these are all real numbers. I mean, we could go ahead and put an R next to all these. Okay? Then you start breaking them down a little bit more. The I stands for your irrational numbers, meaning those numbers that cannot be written as a fraction. Okay? Your Q is your rational numbers. Those are the numbers that can be written as a fraction. Z stands for integers, which are they're kind of like wholes, like there's no decimal or fraction part, but they can be positive, negative, or 0. Your whole numbers are, you start at 0 and then go 1, 2, 3, and so on. And then your natural numbers start at 1 and then you go 2, 3, 4. Okay? So let's start with number 1 here. Negative 14 halves. Well, it's already a rational number, or not a rational, excuse me, a real number. It's also rational because it's clearly written as a fraction, so we can go ahead and put Q. Okay? Notice I skipped I because it's not irrational. Whatever it's not, you don't list. So the next option could be Z, an integer. Can you reduce this fraction so it's not a fraction anymore? Well, yeah, 14 divided 2 is 7. This is secretly negative 7. That's an integer. Okay? It's not whole because it's negative, so we stop at Z. Okay? Square root of 64. If you type that in your calculator, that's secretly 8. Okay? 8 is rational because I can do 8 over 1. It's an integer, it's whole, and it's natural. Right? 0, that's rational. I can do 0 over 1. It's a integer, and it's whole, but it's not natural. Okay, naturals start at 1. Okay, now we got pi, probably one of my favorite numbers ever. Pi, as you all know, is some big god-awful decimal, which means it's irrational. That's as far as we go. 0.45. Now, this one's a little weird. It's going to be a rational number. That's because decimals that are rational have to be terminating, which means they stop. Terminating is one like 0.5, like that stops. Or they can repeat, or the decimal can repeat. So this bar means you've got 0.45, 45, 45, dot, 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 so on and so on. Okay? So it's going to be rational. We can write that as a fraction. And then it would stop because you can't go any farther. And the same thing with 3/8. It's rational. And that's where we stop. Okay? So notice what I did. I would start with real, and then I would work my way down that list. Okay? Natural is the smallest set you can get to. Okay? Now you could be asked a question, list the smallest set to which the number belongs to. So in other words, how far down that list can you go? Okay? So for square root of 64, I would say the smallest set would be the naturals because that's where I'll stop. For 0.45 repeating, it would be Q. I would stop at Q. Okay? Scroll up. Okay. So now we're asked to sort these numbers into each category. Okay? Negative 0.2 repeating. That looks like negative 0.222 ... It's a repeating decimal and it's negative. That means it has to go in the rational spot and it can't go anywhere else. Alright? 18. 18 is a natural number. That's as low as you can go. Because 18 is rational, it's an integer, it's a whole number, and it's a natural number. It goes all the way down here to natural. And in case you don't understand this Venn diagram, what this is saying is this entire big box here with all these circles, this is all the real numbers in the world. And then we close off different sections. So this little bubble here is for all the irrationals. This bigger circle is rationals. And then inside the rationals, you have your integers. Inside those, you have your whole numbers. Inside those, you have your natural numbers. That's how that Venn diagram's working, just in case you didn't know. Alright, negative square root of 100. If you type that in your calculator, you're going to get negative 10. Okay? Negative 10 is an integer, so I'm going to put C up here in the integers circle. Pi, we know, is irrational. 0, it's all these over here except natural. So 0 is going to go right here in the holes. Excuse me. 2 1/6. Anytime you see a fraction, automatically think rational and then see if that reduces. That's not going to reduce, so we're going to leave it as a rational number. Negative 5 is going to be an integer because it's negative. 4.03. That's another rational number. Negative square root of 72. If you type that in your calculator, you're going to get some big nasty decimals. That's going to be an irrational number. Square root of 4/9. If you type that in, you're going to get, I think it's 2/3. Well, 2/3 is a fraction, so that means it's going to be a rational number. 36/9, that is secretly 4 in disguise, so it is a natural number. Alright? That's all stuff about real numbers. Now we're talking about properties. Okay, so this is where we talk about the commutative, associative, reflexive, all that, symmetric, all that stuff, okay? So let's look at what we're talking about here. We've got 4 plus the quantity x plus y equals the quantity 4 plus x plus y. So if I look at this equation, the only thing I notice that's changed is the location of my parentheses. The order has not changed. All I did was scoot the set of parentheses from the x plus y over here to the 4 plus x. That's your clue that this is the associative property, which means that it does not matter who I associate. Okay? Basically, you can move parentheses around and still be okay. Okay? Number 8 says 2/5 times 5/2 equals 1. If you're multiplying something and you equal 1, that's your clue this is going to be the inverse property. The inverse property of multiplication says you take a number, multiply it by its inverse, multiplicative inverse, and you get back to 1. Okay? Number 9, if the square root of 49 equals 7 and 7 equals 3 plus 4, then the square root of 49 equals 3 plus 4. So basically we've got A, we're going to say square root of 49 is A, 7 is B, then you got B and C, and then you end up A equals C. When you have a string like that, that's your clue this is the transitive property. Okay? Because you've got one equation and another one, and you kind of smash the two ends together. Square root of 49 and 3 plus 4 equal together. That's transitive. Negative 28 equals negative 28. When something is equal to itself, that is called the reflexive property. Kind of like when you look in a mirror and you see your reflection, you see yourself. Reflexive. 8x squared times 1 equals 8x squared. What this is saying is you take any quantity, whatever, multiply it by 1 and you get the same thing back. This is called the identity property. And this is identity property for multiplication. Okay? You multiply any quantity times 1, it does not change the value. Okay? 10y plus negative 10y equals 0. This is the inverse property again. But this time it's with addition. If I add the opposite, I get 0. On number 8, you multiply the opposite, you get 1. Whoops, that is not addition. I was getting ready to write addition there. That's multiplication. Let me scoot this up a little bit because I need some room. The quantity a plus 4 times 0 equals 0. This is kind of dumb. Anytime you multiply something by 0, you're going to get 0. That's the 0 property. Okay? You have negative 5 times the quantity x plus 7, and you end up with negative 5x minus 35. This is the distributive property. You all know that. You probably draw it like that. Draw little arrows inside and you multiply. Now, pay attention to 15 here. We start with the quantity x plus 2 plus y. It switches to 2 plus x plus y. You might be tempted to think associative, but pay attention. Look at these parentheses. They didn't move. The only thing we did was switch the order inside. That's the commutative property. Okay? Which says it doesn't matter how you order things in the problem, you can switch the order and still be okay. And then finally we have x equals 1, then x equals negative 1, then negative 1 equals x. This is a symmetric property. Basically, you have an equation, you can turn the equation around and it's still the same thing. Alright, scroll up. Let's talk about closure. If an operation is closed, that means whatever you do to that set, you stay inside that set. Okay? So let's think about this. The set of negative numbers are closed under division. Okay? So can I take any two negative numbers and divide them and still be negative? Well, let's see. Negative 4 divide negative 2. I get 2. Okay, what about negative 10 divided negative 5? I get 2 again. That was just a fluke. I did 2 twice. Let's do negative 16 divided negative 4. I get positive 4. Are we closed? No. You divide a negative by negative, you get positive. Okay. The set of whole numbers are closed under subtraction. Alright, let's see. Let's think out loud for a minute. That's what I like to do. Whole numbers are 0 and up. So let's do 18 subtract 16. That's 2. Hey, there we go. Notice what happens if I turn that around. I get negative 2. This answer, negative 2, is no longer whole. That's an integer. So no, we are not closed. The set of integers are closed under multiplication. Can you take any 2 integers and multiply them together and still be an integer? Yes. Because negative 4 times 9 is negative 36. Well, that's an integer. Negative 4 times negative 9 is a positive 36. But remember, integers can be positive too. So those both are integers, and there we go. Alright. Let's do some absolute value and order of operations. Okay? So anytime you have absolute value, all it does is turn your answer positive when you get done. Okay? So absolute value of negative 21 is 21. Absolute value of 5 is 5. You add the 2 together, you get 26. There you go. Okay? Why does it turn it positive? Well, absolute value, remember, measures your distance from 0. And distance is never negative. Okay? So negative 21 is 21 places away from 0. That's why it turns out to be positive. Okay? Now over here, we got to clean up inside first. Negative 10 subtract 4. That means I'm at negative 10 and I go backwards 4 more. I end up at negative 14. How far away is that from 0? 14. Okay? Now, order of operations means I have to follow PEMDAS. Do I have any parentheses or grouping symbols on number 22? No, I don't. So I go straight to the E, exponents. I see an exponent, 3 squared. So all I'm going to do is replace 3 squared with 9. Because that's what 3 squared is. 3 squared is 9. Okay? Now I go to multiplication or division, whichever one I come across first. So I see a subtraction. Here's multiplication. 2 times 9 is 18. So 10 minus 18 plus 13. There's no division. I have a subtract and an add, so I'm just going to go in order because it does not matter which one comes first. 10 subtract 18 is negative 8. Negative 8 plus 13 should be 5. Yep, 5. Okay? And honestly, guys, once you get to this line, or even here, open up the Desmos Scientific Calculator and type that in. There's no reason you should miss an order of operations problem. Alright, number 23. There's a lot going on here. You have a pair of brackets with an exponent, and then inside the brackets is some other stuff going on. So we have to go inside to the innermost set of parentheses. Right here. Negative 5 plus 1 is negative 4. And we got divide 2 cubed minus, and I'm going to go ahead and do that absolute value just because I know what it is. I know it's 7. Negative 4 divide 2, that's going to be negative 2. Minus 7. Negative 2 to the third power. That is not the same thing as negative 2 times 3, guys. You should know by now what an exponent means. An exponent means you take whatever's inside your brackets here, and you multiply that number by itself 3 times. So we've got negative 2 times another negative 2 times another negative 2. That ends up being negative 8. We're going to subtract 7, so we get negative 15. Okay? When you have a big fraction like this for your order of operations, just start on the top and work it out, and then go to the bottom and work it out. That's what I do. Okay, that's what I'm going to advise you to do, because I think it's just easier. So on top, we have an exponent of 5 squared. That's going to be 25 plus 25, and then a divide 5. I'm going to do each separately. That's why I'm not doing the bottom yet. 25 divide 5 is 5. So 25 plus the 5. So our 30 is on top. Okay, I'm just going to leave it over there for a minute. I'll come back to it. 30 is on top. On the bottom, that looks like we have a division in the middle. So 7 subtract 12 divide 4 is 3 plus 2. And we can go down the line here. 7 subtract 3 is 4. 4 plus 2 is 6. So everything here simplifies. We get 30 on top, 6 on the bottom. That's going to turn into 5. Right? And then let's go do 25. We have parentheses on top. That ends up being negative 4 squared plus 11. Because 3 subtract 7 is negative 4. Negative 4 squared means I do negative 4 times negative 4, which is positive 16. Add 11. That will give me 27 on top. I'm just going to leave it over there off to the side for a minute. On the bottom, absolute value of negative 2 is 2. Absolute value of negative 1 is 1. So I got 3 on the bottom. 27 on top, 3 on the bottom. I end up getting 9. Okay? Those should be pretty easy. You should not miss an order of operations problem. You just follow your PEMDAS. Start with any parentheses or grouping symbols, then your exponents, then multiply or divide, whichever one comes first, and then add or subtract, whichever comes first. Okay. Evaluating expressions. I like these personally. I think they're fun. But then again, I'm a nerd. Alright? So we got 3x cubed minus 8y squared, and they tell us we're going to let x be 2 and y be negative 3. So all I'm going to do is plug my numbers in. Okay? And then if I were you, from this point, I would go to Desmos and type it into the calculator. Because the way I have this video set up, I'm not going to do that, so I'm just going to work it out on my calculator here real quick. Or I can work it out for you while we're here. 2 cubed is going to be 8, and then 8 times 3 is 24. Negative 3 squared is positive 9. Okay, I'm still doing order of operations technically. Positive 9 times negative 8 is going to be minus 72. That's negative 48. Let me double check myself. Yep. Negative 48. Okay, the absolute value of A minus 4B. A is 7, B is 2. So, because this A is positive 7, I'm not going to put it in parentheses. It's unnecessary for me, but if you want to do it, by all means, go ahead and do it. Minus 4 times... I don't know what happened there. That was weird. Okay. 4 times 2 is 8, so we've got... What is wrong with this thing? Hang on. Let me get that out of the way. That's what the problem is. I'm too close to it. 7 minus 8... That's negative 1, so the answer is 1. Let me double check. Yep. Alright. W squared plus 2xy. X is negative 3, W is negative 2, and Y is 1. So I'm just going to plug everything in. Sorry, my pen's having a episode there. I don't know what's going on with it. Okay. Again, from here you could type it straight into a Desmos scientific calculator, but I'm going to work it out. Negative 2 squared is positive 4. 2 times negative 3 is negative 6. Negative 6 times 1 is negative 6, so we got still minus 6. That will end up being negative 2. Just verify real quick. Yep, negative 2. Alright. 7c squared plus 5 divided by 4a minus b. We're going to let a be 1, b be... Well, I've written right through it. I can't tell what that is. Negative 5. And c is negative 4. Alright. So plug everything in. Okay. On top, negative 4 squared is 16, positive. 16. So 16 times 7 gets me 112 plus 5. And on the bottom, I've got 4 times 1 is 4. Negative negative 5, that's really going to be plus 5. So I'm going to get 117 over 9. We end up with 13. Okay? Again, if you don't want to work those out all the way, you can just use Desmos Online Calculator. Let's see how much more we got to do. There's simplify, 2-step equations. Okay, we got a little bit more to do. Alright. Translating. Okay. So I'm just going to read each statement and then we'll see what we have to do. The product of a number and 7 increased by 3. So product means multiplication. So a number I don't know, we're going to use n. You could use any other variable, but we'll just use n because we're talking about number. So the product of a number and 7 is going to be 7n. And then increased by 3 means we add 3. Okay. Notice I'm not going to use an equal sign because I did not see the word is. So this is really just an expression. Okay. 1 less than twice a number. Okay? Obviously 1 less means we have to subtract 1 somewhere, and then twice the number is we double our n, so 2n. Okay? I will bet you a lot of you are thinking this. Okay? That's backwards what it really needs to be. Okay? When you write these expressions, generally you start where the multiplication's at. So we would say 2n minus 1. Okay? 4 times the difference of a number and 9 is negative 30. Okay? So I see this word. I know I'm going to have an equal sign somewhere because I'm making an equation. And then negative 30 is going to go on one side of it. Now we're going to figure out 4 times the difference of a number and 9. Okay? We know times is multiplication, so we have to multiply somewhere. But notice it says times the difference of a number and 9. Okay, so this is the difference part. The difference of a number and 9 means I take a number and subtract 9 from it. And then based on what it says, I have to multiply everything there by 4. Because it's 4 times the difference of the number and 9. I gotta multiply that whole difference by 4. Alright? 5 more than the quotient of a number and 8 is 42. So again, notice that the quotient comes later. We're going to start there. I see is, so put an equal sign. 42 goes on one side. Quotient means divide. What am I dividing? A number and 8. So n divide 8. That's supposed to be an 8. And then 5 more, we add 5. Okay? The auditorium can hold a maximum of 150 people. So let's think about this for a minute. If it says maximum, that means you cannot go over 150. Okay, so we know we're talking about 150. You can't go over, so you need to be less than 150. Okay, it's got to be smaller than that. Can you be 150? Like, can the auditorium actually hold 150 people? Yes, it can. So we put the equal sign, and then we put our variable. So our number of people has to be smaller than or equal to 150 in order to be the maximum. Okay? And then 35 is kind of opposite. At least 25. So now we're talking about 25. You have to be at least bigger than 25, or you can be 25. Okay, so anybody that's 26, 30, 40 can rent a car, but somebody that's 24 can't be because they're not at least 25. So here you would use the greater than symbol and equal to. Alright, simplifying. Oh, I love this. Combining like terms. Love it. So let's find our friends. I have what number is in front of this n? There's nothing there. Yeah, there is. There's an invisible 1. I have a single n and I take away 5 of them. That gives me negative 4n. And then 4 subtract 9 is negative 5. Okay? You will probably see your answer written that way. If you do this, though, that's fine. I mean, you're still correct, but generally the variable comes first. So either one of those will work. Okay? I see 7x, subtract 3x, that gives me 4x. Negative 4y, I take away 8 more, that gives me negative 12y. Negative 8 plus 12 is plus 4. Okay, and again, if you switch the order around of those, that's okay, but generally you start with x, go to y, and then your constants. Okay? I would distribute on number 38 first. So we got 18. Negative 2 times 4 is negative 8x. Negative 2 times 7 is 14. I generally start with my variables, so negative 8 plus 5 is negative 3 x's. 18 subtract 14 is plus 4. Or you could do 4 subtract 3x. I mean, it really doesn't matter. But you're probably going to see this first one. 39 we have to distribute twice, so let's do the first one. I get 9x minus 27. Now be careful here. You're subtracting both of those. You're kind of technically distributing a negative 1. So we got negative x minus 2. Make sure you distribute the negative to both of those. We'll end up with 8x minus 29. Alright. Some applications. We got perimeter. You know, perimeter means the distance around. Basically, I'm going to look around on this triangle. I'm going to add all three sides up. 2x plus 3x is 5x. 5x plus 1x gives me 6x. Negative 6 plus 1 is negative 5. Negative 5 plus 8 is a positive 3. That's what I do. I just go around and just add up your terms. Now on a rectangle, what I saw a lot of kids do, they would just add these two together and stop. Well, you forgot the other two sides. You have another v minus 5 over here and another 2v plus 13 up here. Then we can just go around and add. 2v and 2v gives me 4v, and then 2 more v's gives me 6v. 13 plus 13 is 26. Negative 5 but negative 5 is negative 10. 26 minus 10 is 16. Okay. If you wanted to, you could list all those out and match up your terms. I just kind of did it in my head. Alright, two-step equations. So now with equations, what I think about it is you want to do order of operations backwards. Okay? So I'm not going to get rid of this 3 multiplied by the x here first. I'm actually going to get rid of the negative 7. When you move something to the other side of this equal sign, you do the opposite. So you would add 7. Add 7. 3x equals 18. Now 3x means 3 times x. To get rid of multiplication, you would use division. So divide 3. X equals 6. Alright? Same thing. Some people like to draw this bar down through here with the equal sign. I mean, you can do that. I don't do that. I'm just doing it for show here. But again, it's your option. Remember, we get rid of the addition or subtraction first. So we got add 8, so we're going to subtract 8. X divided 4 equals negative 5. Okay? We're already dividing. How do you get rid of dividing? You multiply. Here's what I do. I multiply by the 4 up here and over here. That makes it go away. So we'll get x equals negative 20. Okay, let's do a couple more. Excuse me. Okay. Well, I don't want to go all the way down. Hang on. Whoops. Got rid of the whole thing. We start with subtract 3, so we add 3 to make it go away. 2/5 x equals negative 14. Okay. Here's what I do when I have a fraction as my coefficient. You are multiplying that x by 2/5. We're going to use that inverse property we talked about way earlier to get rid of this. Okay, it's called multiplying by the reciprocal. So we're going to multiply on both sides. And the reciprocal of this fraction, 2/5, would be 5/2. Okay? Now if you don't believe me, type that in your calculator. 5/2 times 2/5. You're going to get 1. So in other words, all that goes away and we're left with just x. And then negative 14 times 5/2 should be negative 35. You double check. And you can use your calculator on there for that if you want to. Yep. That's my answer, negative 35. Okay? Now, 45, they're trying to trip you up. Because most of the time, whatever's added or subtracted is written second in the equation. They're trying to see if you're paying attention. This time they've put the variable term second. Okay? You never, ever, 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 ever start at the variable. Okay? You always start with the term that doesn't have a variable. In this case, it's in front. That's a positive 9, so we're going to subtract 9. Forgot my line. Negative 7x equals 7. Sorry, had a brain fart for a second. Divide negative 7. X equals negative 1. There we go. Alrighty. Again, they're trying to trip you up. Never start the variable. Always start with the constant term. Put my line. Minus 9. Now notice there's a negative there, so I have to leave it. Negative 3/4 x equals 48, I think. Sorry, I'm trying to do that in my head. I probably shouldn't do that. Yeah, 48. Now, notice I have a fraction as my coefficient. I'm going to do the same thing I did up here on number 44. I'm going to multiply by the reciprocal of negative 3/4. So multiply, multiply. The negative stays, and we flip the fraction. That's gone. X equals. And then you can use your calculator for this part. 48 times negative 4/3. I think it's going to be negative 64. Let me double check. Yep. Negative 64. Okay? Now, up to this point, I have told you you start with the constant term that's being added or subtracted. That's where you start. That all holds true unless your equation is written like number 47, where you see the x and the 17 are being divided by 3. This is the only case where you would start with the division, because you have to get rid of that fraction first. Okay, it just makes your life easier if you do that. So we are dividing by 3, so I'm going to multiply by 3 on both sides. And the only thing that does is get rid of the 3. X subtract 17 stays the same. I didn't change that. And then negative 3 times 3 is not negative 9. Then I'm going to add my 17. That should be 8. I really don't trust myself sometimes. Whoa. Yeah, 8. Alright. on to inequalities, which kind of work like equations. They're almost identical to equations, except there's a couple differences we have to remember. And when those pop up, I'll remind you. Okay? As far as solving it, it does not change the same. We still start with the add or subtract and get rid of it. So 3x, that was originally less than 9. Divide 3. X is less than 3. So there's our solution. Now, notice that when we talked about an equation, we got one single answer that made that equation true. When you have an inequality, this time you're going to have multiple answers that makes that thing true. Okay? Now, we want this to be x is less than 3. And it always helps if your variable is written first, because it helps making your number line the same, or help makes your number line easier. And this is a blank number line, so you can put any numbers on here you want. If we're referencing 3, I like to put 0 in the middle. 1, 2, 3. And this would be negative 1, negative 2, negative 3. Okay, so we're referencing from 3. So because this is strictly less than and not equal to, we would have an open circle. Now, I know your lesson had you draw it above the number line. I was taught to draw it on there. You can do it above if you want to. Actually, let me do that because that's what you were showed. And then it really helps if your variable's written first, because whichever way this thing points, that's the way you draw the arrow. Okay? That only works if the variable's written first. Okay? If it's not, you can turn things around so it is. Alright. Let's do this one. Subtract 2, subtract 2. Negative 5x is greater than or equal to 50. So I'm going to divide my negative 5, divide my negative 5. So here is where that thing the difference comes up. Inequalities are different because when you multiply or divide by a negative number, at any point, I don't care when you do it, any point, you must turn that sign around. We started with greater than or equal to, so now we're going to say less than or equal to. And then 50 divided negative 5 is negative 10. Okay? Now, if you want to, as far as putting your numbers on here, you can just make sure you have negative 10 somewhere. Like you could put it in the middle. And then negative 9, negative 8, negative 7, negative 11, negative 12, negative 13. Because this is equal to, we would put a closed circle, and then we're going to go that way. Okay, let's do, how much more we got? Okay, almost done. Alright. Remember your original sign in case we have to flip. So there's an 11 here, so we're going to get rid of that. X divided negative 2 is less than or equal to 4. We're dividing by negative 2, so we multiply by negative 2. Now, remember, the rule is when you multiply or divide. So we multiplied here by negative. I still have to flip that around, and I would get negative 8. We can put negative 8 in the middle, negative 7, negative 6, negative 5, negative 9, negative 10, negative 11. Okay? So we have equal to, so we put a closed dot and then shade that way. Alright. Keep going. We have minus 1, so we're going to add 1. 4x is less than or equal to negative 36. Divide 4. Now, you might be tempted to switch this sign. But did I divide by a negative number? In other words, is my 4 down here negative? No, it's not. So you do not flip that sign. Okay? You would only flip it if the bottom, if the 4 was negative. Put negative 9 in the middle, negative 8, negative 7, negative 6. Put our dot. We have the equal sign bar, so we're going to close it. And then we shade to the left. Remember, if the variable is first, you shade whichever way this arrow points. Alright. I don't need to scoot it up anymore. Last 4, sorry, there's 4 of them. Never start with a variable. So we add 1. 5/8 x is less than or equal to 10. Our coefficient is 5/8, so I would multiply by 8/5 to make that go away. So x, and it's not negative, so I'm not going to flip. 16. Yep. Alright, 16 in the middle, 17, 18, 19, 15, 14, 13. I would do an open, or not, sorry, excuse me, closed, because I have the equal sign, and then I would shade that way, to the left. Now, 53, they're trying to trip you up again. Your variable term is in the middle. Do not start there. You start with the other term. So minus 4, minus 4. Negative x divided by 7 is less than 1. Now, what I'm going to do here is I have a negative here with my x, and I'm dividing by 7. I want both of those to go away because I want a positive x when I get done. So I'm going to multiply by negative 7. That makes all that go away, and I'm just left with x. And I multiplied by a negative, so that less than now becomes greater than negative 7. So we're going to put negative 7 in the middle, negative 6, negative 5, negative 4, negative 8, negative 9, negative 10. This time the dot's going to be open because I have no equal bar. And then we shade to the right. Alright. Variables in the middle. Don't start there. Start with a thing without a variable. So minus 18. Minus 18. Negative 2x is greater than 4 subtract 18 is negative 14. Divide negative 2. You divided by a negative, so that greater than now becomes a less than. So 7 in the middle, 8, 9, 10, 6, 5, 4. Let's put us a dot on 7. It's going to be open because there's no equal bar. And then we shade to the left. Now, I have written through my problem here. There we go. Again, variables in the middle, so we start with the thing without the variable. Subtract 8, subtract 8. Negative 3 halves x is greater than or equal to, I think that's negative 25. No, it's not. No, it's not. That was bad math. I'm sorry. That's 21. I'm pretty sure. Let me double check. Yep. Negative 21. Sorry about that. Now, my coefficient's a fraction, and it's negative. So, we're going to multiply by the reciprocal. We're going to flip that fraction. So, negative 2/3. We multiplied by a negative, so this greater than or equal to now becomes less than or equal to. And then 21 times 2/3 is going to be 14. Let's put 14 in the middle. 15, 16, 17, 13, 12, 11. It's less than or equal to, so we put a close dot on 14, and because that variable's in the front, we're going to shade that way, draw our arrow that way. Alright, I think that is all the questions on the study guide. Okay? Now remember, this is just for your benefit. I expect you to have already worked this out when you watch this video. Okay, the video is only supposed to help you either get unstuck on a problem, or you want to verify your answers, or you're lost and need a little guidance to figure out how to do it. Okay? It should not be that you are copying my answers down. Okay, that's bad practice. And you will not pass the test if that's all you do is copy my answers down. Okay, you are going to fail the test. So please be prepared and show me that you've learned something for our first unit of online learning. Good luck.